Hello everyone. Today I'm going to be going through the first 5 questions of the 2014 Old Advanced Higher Chemistry paper. For more study tips and stuff, go to rishisubjects.co.uk where you'll find a vast repository of past papers. On to the first question. The energy associated with a photon of electromagnetic radiation is, and then we have the 4 options specified here. The formula we need to use for this question is E is equal to hf. Energy is equal to Planck's constant times frequency. As we can see, since Planck's constant does not change, as the frequency increases, the energy must also increase, which means energy is proportional to frequency, meaning the answer is B. For question 2, we have to use this formula along with Avogadro's constant in order to work out the energy in kilojoules per mole. The unit here is very important. Let's see why. Since we use c is equal to f lambda, which is just v in this case being speed of light, we can rearrange the equation to do E is equal to LHC over lambda. Afterwards, we just substitute the values. Avogadro's constant is L, which is found near the end of the data booklet. Planck's constant is also here. The speed of light is here, so we just have a bunch of constants on the top side, and then we have the wavelength on the bottom, which in this case is 501 times 10 to the negative 9. Don't forget the nano. Then we have a value that is in joules per mole, but we need kilojoules per mole because this is the unit here. So we just divide this by 10 times 10 to the 3, and then we get the answer C, 239. Do not fall for the trap and put D. For question 3, the electronic configuration of a vanadium atom in its ground state is, and we know that vanadium's atomic number is 23, and it has this particular electronic configuration. So we look at this table, and this is the order in which the electrons fill it. Credits to Jatkin for the visual, and as we can see, 1s2, 2s2, 2p6, 3s2, 3p6, 3d3 and 4s2. We order it. The reason why it's up 4s and 3d is because we order it by the principal number first. So it's just all of the 1s grouped, all of the 2s grouped, all of the 3s, and then all of the 4s. Then in order to check our answer, we just add up all of the numbers. So it will be 2 plus 2 plus 6 plus 2 plus 6 plus 3 plus 2, which results in 23. Therefore, the answer here is C. We just compare it against what we got. For question 4, in absorption spectroscopy, as the concentration of an ion in solution increases, there is an increase in the, and then we have the formula for absorbance. Now, one second, pointer options, disable the laser pointer. Now, let's see what happens when we change the value of C. As you can see in this visual, the absorption is directly proportional to the concentration. So that means that when the concentration of an ion in solution increases, the intensity of radiation absorbed also increases. Now on to the final question we're covering in today's video. Which of the following compounds is likely to show the least ionic character? So we need to calculate the difference in electronegativity. For potassium, it is 0.8, chlorine is 3.2. When we subtract them, we get 2.4. For potassium, it's 1. For oxygen, it's 3.4. So when you subtract them, it becomes 2.4. For fluorine, which is 4. And for boron, which is 2, which is C, it's 4 minus 2, which is just 2. But for phosphorus and hydrogen, we have 2.2 from both. And that means that it's 0 since we subtract them from each other. So therefore, the answer here is D, as it has the least ionic character, not the word least in this question. So the answer is D. Anyway, thanks for watching this video. Subscribe for more chemistry related videos. And as always, go to rishisubjects.co.uk for more information regarding chemistry and other subjects like maths. Have a good day.